Hello students, welcome to this lesson. Well, in this lesson I'll be presenting a question about functions, and it is based on the parabola in the straight line, and I'm helping you to be able to get the values of variables, especially when an equation is given with unknowns throughout like this. F of x is equal to x squared plus bx plus c and g of x is equal to 6x plus q, right? We see that f of x is given in standard format, okay? And also g of x is given in standard format. Okay, let's go to the sketch. We're given the full coordinates of the x-intercept. We are again given the full coordinates of the x-intercept. -3, 0 there, 2 and 0 there. Okay, what is this? We're given the full coordinates of the point of intersection, and we understand that at the point of intersection, f of x is equal to g of x. So this is g and that is f. Okay, what is the meaning of this equation? Let's follow it. We are saying that the x coordinates of these two functions, they are the same at that point. In this case, that point is D. We are also saying that f of x and g of x, both of which mean their corresponding y coordinates to this x value, both of them have the same y coordinate. Okay, so we are talking about this. This is -8, and that is what? 1 for both functions. Great stuff. Now look at the very first question. Determine the values of a, b, and c. These are the constants in the parabola. Okay, so which method can we use here? Okay, we're given the x-intercept, we're given the x-intercept. So the x-intercept format of the parabola can help us here. All right, so let's write it in x-intercept format. So f of x can be written as this: x minus x1. x1 means the first x-intercept. X minus x2. x2 means the second x-intercept. Okay, so let us substitute. F of x equal to a, x what? Minus, what's going to happen here? That's your x1. I'm going to produce a double negative. X minus x2, it's a 2 there. Okay, so it's just -2. Okay, fix your stuff. A double negative gives you a positive. So it's x plus 3 times x minus 2. Okay, so let us understand that this x is the same as that x, because when you multiply out, you're going to form an x squared, you see. So the substitution you make for this x will be exactly the substitution you make for that x. They are the same. It's just the difference that we have made there in the equation by convention to say, let us differentiate the x-intercepts, since generally they are different numbers. Okay, so if we can get another point on the graph that we can substitute for the x coordinate and here for the y coordinate. Remember, f of x is just a notation that we give to differentiate the functions if we have more than one. Okay, so is there another point? Yes, D is a point of intersection. It's also a point on F, is a point on G. So we're right to use it on F. So your Y is your -8, and then your X is 1. So we put in -8 for Y, and then it's A. What is the X? So it's going to be 1 plus 3, and then 1 minus 2. Okay. So what do we have on the right hand side? A times what? This is 4, 1 minus 2, -1, 4 times -1, it's -4, divide both sides by negative 4, therefore a is equal to what? A is equal to 2. Did we expect the coefficient of x squared to be positive? Yes, because when you look at the sketch of f, it is a concave up parabola. Okay, so you reduce the equation to this now. F of x is equal to 2, what? X plus 3, x minus 2. Okay, so if we expand this product, we should easily get the values of b and c. So let's go for it. 2, we have x squared in there, it's minus 2x plus 3x. This will give us x, and then 3 times negative 2 is minus 6. Distribute the 2, you have 2x squared plus 2x minus 12. Okay, so b is equal to 2 and c is equal to negative 12. In standard format, the value of c gives you what? I hear y-intercept, correct. So we are saying that the graph cuts the y-axis here at negative 12. All right, good stuff. We are done with A. B, determine the coordinates of the turning point. Turning point, as you can see, it's there. All right, so we expect the x coordinate to be negative and the y coordinate to be negative, because there's the y coordinate and the x-intercept, sorry, the s coordinate, it is to the left of 0. So it's very important to make sense of your answers, okay, in relation to the sketch. So coordinates of the turning point, actually it should have read coordinates of the turning point of f. Okay, just to complete the question there. Of course, straight lines don't have a turning point, they are straight. So f of x is equal to 2x squared plus 2x minus 12. Okay, so the turning point at this stage in our learning of the subject, we know this formula. X is equal to negative b over 2a plus or minus, right, square root of b squared minus 4ac all over what? 2a. Okay, you may know it slightly differently when both of these numerators are over 2a, which is true, of course. However, I wrote it separately because I want to explain the fact that it is split. Okay, this has a meaning. What is the meaning of this part of the equation? This is the equation of the axis of what? Symmetry. Okay, so this line, this imaginary line that cuts the parabola into two halves, we call that the axis of symmetry. So what this equation is saying is that from the axis of symmetry, there is a root to the right of the axis of symmetry, that's hence the plus. There's also a root to the left of the axis of symmetry, hence the what? The minus there. Okay, as you can see, if you go to the right, there's a root, there's an x-intercept. If you go to the left, there's a root, that's the x-intercept. Okay, while a root means also the x-intercept. It's another word for x-intercept. So be conscious of this fact, right? That we mean that this one will help us to determine the roots. And that's why when we talk about nature of roots, when we classify nature of roots, we use the discriminant, b squared minus 4ac. If it's 0, it means there's one, x-intercept, and at that x-intercept, our roots are equal. It will only touch the x-axis like that, and the roots can also be rational and irrational and things like that. So it's very important to understand the meaning of what we're doing, the equations we're using in mathematics, which allows us to solve problems. Good. So let's get the x coordinate then of the turning point, and the axis of symmetry will go through that x coordinate, okay, as it cuts through the x-intercept. So the equation is x equal to negative b over 2a. So if you have the full equation, you can see this is your a, this is your b, and this is your c. So x is equal to negative, what is your b? It's 2 over 2a. What is your a? It's 2. So it's 2 over 4, it's a half. So it's negative half. We expected this to be negative half. Good. How do we get the corresponding y value? You get it by substituting for x in this expression and getting the y value. I give it to you as homework. All right, so you'll do that later on at your convenient time. The last question. Get the value of k. What is k? K is the y-intercept. If the linear function is given in standard form like this, this is just a constant. In place of c, as we usually know it, there is k. So it doesn't change the meaning, we just change the variable or the letter. So it's a y-intercept, okay? So in other words, we are looking for a point we can substitute, which is on G, to solve for k. Is there a point on G? Yes, it's D. It's on F and G. So we're going to use D, which is 1, negative 8. That is your x, that is your y coordinate. So we have G of x equal to 6x plus k, and this is negative 8 equal to 6 times 1 plus k. It's a positive 6 there, you transpose to the left, and it becomes a negative. Negative 8 minus 6. This gives you k to be negative what? 14. And look at this, it makes sense. There is your straight line cutting the y-axis at negative 14, just below the y-intercept of the parabola f. Okay, so it makes sense. You should be worried if you maybe got a negative 3 here, you know, or a number that is greater than negative 12. So your answer must speak to your sketch or your equations. All right, there must be that alignment throughout. Okay, so grade 11s, thank you for tuning in. I'm going to leave it here. Remember your homework. Also, you know, study more on nature of roots. It's an important aspect of this big topic called, you know, functions or algebraic functions. Thank you for tuning in. See you next time. Sharp, sharp.